Example 8. Actually, after a while, you learn how to sieve out important information. Like for example, you see n equals to 250. All right. Sample size, this is summation x and summation x bar. Why like that? Where did this come from? Anyway. But you realize that these example 8, 9, 10 are a bit different because you look now, you've given now H0, H1, but the level of significance, interestingly, is an unknown. Correct? Usually, level of significance 5%, 10%, then key in GC, we're done. But in this case, the question is find the set of values of alpha, and you are given this conclusion that null hypothesis is rejected. So you are not required to make conclusion. The conclusion is given to you. All right, the conclusion is given to you. All right, so we solve this part first, then we ignore this first, okay? We ignore this and see how we can solve this part. My advice to all of us is this. If you are stuck and you really don't know how to start, just follow the normal process. Just do a step 1, 2, 3, 4, 5. Okay? Okay, let's start with step 1, 2, 3, 4, 5. We define. But before that, of course, we need to find unbiased estimate of the population because variance are known, so we find these two, no problem. You okay what I mean? Because you have population, right? And you are given n is 250, right? Sigma square unknown, right? Sigma square unknown, die you have to find S square, right? From here. So die you have to find this. Die you have to find sample mean 47.48. This one quite easy. Don't want to go through. Correct? Don't want to go through. Now, as I said, don't know what to do, just follow steps first. State the null hypothesis, state the alternative hypothesis, step 1. State the level of significance. Never mind, we don't know, just leave it as alpha percent. Never mind, leave it like that. Okay, don't know, never mind. Again, do the same thing, write down a test statistic. Look, n is large. So Z test, not T, okay? Z test. And because n is large, this 330.99 is a constant, more or less constant. It's not a variable. It's a very good estimate for the population variance. Then we get this. Now the difference between example 8 and the previous examples then is that I cannot use GC anymore. Alright, I cannot use, can I? Actually still can. Because GC didn't ask for level of significance. Correct? Can I use GC? Can. By GC, you can still find a p-value. Okay, good. Let me do this. Can we give yourself about 1 minute to find out the p-value? Use GC, come on. Pause the recording. 0.040180. Correct? This is by GC. Z test, not T test, okay? Because n is large. And then actually from this, then how would this come in? How do you find the set of values of alpha? So if we follow the same process, look, you know the conclusion is rejection of H0, right? Given in the question. So, to reject H0, p-value, okay, this one you fill in yourself, okay? This must be greater than or smaller than or equal to or whatever, okay? If I reject, this p-value must be what? Smaller, right? Smaller than or equal to. Okay, some of us will start to question, why must have this equal to sign? I'm not going to answer now, but just remember this by convention. Okay? Not going to answer now. Okay? Just remember it's smaller than or equal to. To not reject, there is no equality sign. To reject, there's an equal sign. Okay? Therefore, 0.040180 must be smaller or equals to. Significance level is here. But we must compare apple to apple, okay? Because the question says alpha percent, I cannot compare this with smaller equals alpha because I convert alpha, percent is actually alpha over 100. Right? Hence, alpha must be greater or equal to 4.0180. So if you have one set of values, round to 3SF, I get this. Okay, let's do the finish. Just give me 1 or 2 more minutes to finish up, okay? The last part, otherwise it's hanging there, very funny, very strange. Look, can you have attention? Last part, let's look here. Last part, just 1 or 2 more minutes. It is subsequently found that the population mean, that means mu, is 45.292. Standard deviation, sigma not sigma square, is 18.761. That means, can you have attention? It's already given you. No need to test anymore. Find the probability of a random sample of 250 giving a sample mean as high as the one found in the sample above. This is not a hypothesis testing question anymore. Now this is given. If this is given, X bar should follow a normal distribution with 45.292. Sorry. This is stat 6 question. Correct? Something divided by n, right? Divided by 250. Correct? 18.761 square. Correct? If X is normally distributed, X bar must be normally distributed like that. You want probability greater than what? Greater than the one found earlier. What was the one found earlier? Whatever lah. 47.488, right? This one. This part is not really a hypothesis testing question. This is a stat 6 sampling distribution question.